Now there's a little bit of a challenge that we experience if we're trying to add fractions. Let's go back to our brownies in the tray model. So we'll important for this example. We're going to start with a square tray, and I'm going to try to make that represent 1/3. So that would be splitting it into 3 equal parts with 2 dividing lines. And I'm going to claim one of them. Remember that the number on the top, the numerator, is the number of pieces. The number on the bottom talks about the size of those pieces. If I look at this tray and I compare it to another tray that I want to have represent 1/4, then we can put in 4 little sections and claim one of them. Now the difficulty becomes if we try to add these together, because if I want to try to take out the brownies that I have and look at how much they fill up together, then I've got to start with something that is 1/3 big, and then I've got to put next to it a smaller piece that is about 1/4 big, and I have to estimate how much I have filled in with both of these pieces together. Maybe it looks like 1/2, it's a little bit more, it's difficult to tell, and that becomes the challenge of adding these directly. We can't do it. There's no way of being able to compare how much we got. So if you want, think of this in terms of a story. Imagine that you prepared 2 different trays of brownies for 2 different parties, and you went to one party, and the people there only used 1/3 of what you brought. You go to the other party, and people only ate 1/4 of what you brought. Maybe you'd like to better understand how much you should make the next time you go to these parties so you don't have so much waste. Well, the really creative solution to do here is to divide the brownies in the same way as both parties. So let's take a look here. This is something that is not going to be helpful, so I'm just going to box this off, bracket it off, with a little bit of a question mark for what that is. But if we go back to our diagram here, watch what happens if I divide the first tray into 4 parts, but I'll do it in the other direction. And then the second tray I'm going to divide into 3 parts so that it matches what happened with that original party. Now, if I'm looking to combine all of these pieces, I can do that in a square tray, and to set myself up, I'm going to divide this tray into 12 pieces. Now I can take the 4 pieces that I was given from this diagram and fill it in. And I'll take the 3 pieces from this diagram and add those as well. And what we see is that we have 1, 2, 3, 4, 5, 6, 7 for our quantity of 12ths. We have 7/12ths worth of a brownie tray that has been filled in. This is how we can add fractions. It's just by simply making them have a common denominator, a common size for their brownies. So let's look at what that would be if we were going to work it algebraically. We started with 1/3, and we're going to add to it 1/4. Now the first thing we did was that we cut up the brownies similar to each other. We did not add these directly. So in doing so, we turned the 1/3 into 4 of 12 pieces. Remember, we can see that right up here. There's 1, 2, 3, 4 pieces out of 12 total slots. And the second one, when we broke it into 12 pieces, became 3 of 12, which together got us the 7/12ths when we combined them. This is called making a common denominator. It's an action in which we look at how we can make the number on the bottom the same so that we can combine the size of the brownies in an easy way. And now that we know what we're looking for, we can see how we can use just numbers and not so many pictures to describe this. We'll start with taking the 1/3 and recognizing that what we did to make the 4/12ths is that we made there be 4 times as many pieces, but in doing so, each piece was 1/4 the size. So instead of there being 3 total slots in the brownie tray, there are 12. And instead of there being 1 piece that we were given 4 of the smaller. Now, if we take a look at the next one, that was where we had 1/4, and we made there be 3 times as many pieces, but each piece was 1/3 as big. It was cut in 3 pieces. So that's another way that we can now show our work when we're making a common denominator and trying to add different fractions.